Density Determination Lab. Prelab discussion. Chemistry is the study of matter, which usually is defined as anything that has mass and volume. You already have some experiences determining mass in the laboratory. In this experiment, you will measure volumes of different materials using direct and indirect methods. You also will use the relationship between mass and volume of a substance to find its density. Volumes of liquids are measured directly in a graduated cylinder. Liquid quantities are dealt with in the laboratory usually are expressed in milliliters, although larger quantities may be expressed in liters. Volumes of regularly shaped geometric solids can be calculated from direct measurements of the dimensions. For example, the volume of a regular solid is calculated by multiplying the length, width, and height. Volumes of solids usually are expressed in cubic centimeters or cm3. Many solids do not lend themselves to direct measurements of the dimensions. These include irregularly shaped objects such as rocks and regularly shaped objects that are too small to be measured with accuracy. Volumes of solids can be measured by water displacement. If a solid is immersed in a liquid such as water, the solid will push aside or displace a volume of water equal to its own volume. Thus, each milliliter of water displaced by the solid represents 1 cubic centimeter of solid volume. Density is an important property of matter, by itself or in conjunction with other properties. Density can be used to identify substances. Density is defined as the quantity of matter in a given unit of volume. This relationship is expressed mathematically as density is equal to mass over volume, or D is equal to M over V. You will be expected to use the measuring skills and techniques developed in earlier laboratory sessions and in the first part of this experiment to find the mass and volume of different substances. You will use these data to calculate the densities of these substances. The purpose of the lab is to learn and practice techniques and calculations for determining the volume and density of a substance. The equipment includes a laboratory balance, a centimeter ruler, a graduated cylinder that is 10 mLs, a graduated cylinder that is 100 mLs, a beaker that is 50 mLs, scissors, thread, safety goggles, and a lab apron or coat. Now for the procedure. Measure and record the dimensions, diameter, and length of a section of glass rod. So I'm going to measure the diameter first. The diameter is 1.2 centimeters. So I'm going to record that here, 1.2 centimeters. The length of it is 4.9 centimeters. 4.9 centimeters. Measure and record the mass of the section of glass rod. So I'm going to turn on my balance. The mass is 13.96, so I'm going to record that here. 13.96 grams. Then it says fill a 10 ml graduated cylinder with tap water to about 7 milliliters. Well, since this is much larger than a 10 ml graduated cylinder, I'm actually going to use a 100 ml graduated cylinder. I'm going to fill it up till it gets to 70, about 70 milliliters. That's 70 milliliters. Okay. Then it says tie a piece of thread around the glass rod as shown. So I'm going to take a piece of thread, piece of string, tie it around the glass rod, lower the glass into the water in the graduated cylinder until it's completely submerged. So I'm going to lower it into the water until it's completely submerged. Do not allow it to touch the sides or the bottom of the cylinder. Well, I can't really stop from touching the sides, but I can stop from touching the bottom. Read and record the volume. The volume is about 76 now. So it went from, let me record the volume over here. Original water level was 70, final water level 76 milliliters. Okay, number 5. Repeat steps 2 and 4 with two different irregularly shaped objects. So the mass of the rock for the first irregular shaped object, the mass is 9.43. The original volume in the graduated cylinder is 69 milliliters. And now I have to tie my rock onto the string. Then I've got to submerge the rock into the graduated cylinder. And the volume goes up to 70, around 74. So the volume becomes from 69 to 74. So now I'm going to do my regularly shaped object. I'm going to use the same regularly shaped object that I used before, but this time I'm going to mass it. The mass is 68.01. 68.01. And the original water level now is still 69 mLs. So I'm going to record that. Original water level is 69 mLs. I'm going to now place this regularly shaped object into the graduated cylinder, and the volume goes up to 76. 76 ml. Okay. Measure and record the mass of a 50 ml beaker. Okay, so that's a 50 ml beaker. The mass of the 50 ml beaker is 28.79. And it says add 50 pellets to the beaker. Measure and record the mass of the combined pellets in the beaker. So the mass of the beaker plus the pellets is 60.93. Now I have to add the pellets to the graduated cylinder. Okay, that's about 70 mLs. Now I'm going to add, so the original water level is 70 mLs, and I'm going to add the pellets. And the volume goes up to 75. Now add about 10 mLs of distilled water to the cylinder. Measure and record the combined mass of the cylinder and the water. Alright, so the mass of the cylinder is 39.24. Okay, now I'm going to add 10 mLs of water. So that's about 10 mLs, and we're going to mass it again. And the mass comes out to 49.09. Okay, all right. I'm going to pour the water out, dry my I'm going to add unknown liquid 1. I know what unknown liquid 1 is. It is ethanol. It's ethyl alcohol. So I'm going to add that to the 10 mLs of ethyl alcohol. I know the mass of the cylinder is 39.29. So the new mass becomes 47.16. I'm going to add my other unknown liquid, which is actually 2-propanol. And the reason I'm telling you this is because in the end we have to calculate the densities of these liquids. So if our calculation is correct, the densities should match up. 10 mLs. And it comes out to 47.32. Okay, so now the only thing left to do is the calculations.